I will check it and I will try to answer. Okay. Okay. So first, WAN interconnection solution and technology overview. We know the WAN network, the wide area network, have a long history, right? And in the old time, long time ago, the WAN interconnection, the WAN, not WAN interconnection, the WAN, wide area network, only concern about the connectivity, like as long as I can provide the connection between the different sites, between the different customers, that will be all. That will be it. But nowadays, the WAN interconnection is not only focused on the connectivity, only concerned about the connection. That is not the only the thing one care about. Nowadays, WAN actually, because the services running on WAN is very different compared to the old time. So the WAN really care about the services, like whether they can provide the good services for the customer, whether they can provide the security, or maybe a robuster connection for the service for the customer. So this is now the WAN requirement, the customer requirement for the WAN is different. Okay, so for this course, first we will focus on the WAN interconnection technology, and also we will focus on the application scenario, and we also will talk about like normally how is the company create a WAN interconnection. Okay, so upon completing this course, you will be able to describe the basic architecture of the typical WAN, and also you will be able to describe the interconnection networking technology and their application scenario. Then you will be able to understand the reliability technology and the optimization technology for the WAN. Okay, so let's look at the basic concept first, like the basic architecture of the typical WAN interconnection solutions. So first, the student must understand like what is WAN. So WAN basically is based on the distance, like how to define WAN based on distance. Like if this network provides the interconnection services across the region, city, country, etc., this long distance area, like between them is a long distance area. Those network is what we call WAN. Okay, is what we call WAN. So normally, most of the time, since it is a long range transmission for the data, normally we will use optical fiber to use as an interconnection media. Okay, so but today's topic is a slightly different of the concept WAN, because today we're talking about the enterprise WAN interconnection, the enterprise WAN interconnection. So the enterprise WAN interconnection basically means that I will use this network, use this WAN network to provide the connection between the between the headquarters, between the branch, between the data center, between the DCs, or maybe other like fixed office or mobile office, etc. So so you can look at this picture in the left, in the right side, and you can see the enterprise. They do not care about what is your physical network, what is the WAN network, the physical WAN network. The enterprise do not care. They only care about the connection, whether I can connect with the HQ and the branch HQ with the data center, branch with the branch. This is the enterprise care about. So for the enterprise themselves, they were thinking, they will call this as a WAN interconnection. Okay, for them, it is like this, because they do not need to understand what is how is the network like for the ISP, like between them, what is the network really looks like? They actually do not care. What do they care is I can connect with each other. That will be all. So let's talk about WAN interconnection in the rest of the course. Okay, about the WAN, maybe later when we talk about when we talk about the next when we talk about the SRv6, those kind of technique, we will talk about the WAN again. Okay, so for this course, for today and tomorrow's course, we will talk about only talk about the WAN interconnection. So let's look at the major enterprise WAN interconnection modes. Like how is the between the HQ, between the branch, how did they create the interconnection? So generally, enterprise WAN can be interconnected in those modes. First, we can use the carrier transmission or MPLS private line. Those two techniques, those two private line, basically, you can rent from the carrier, and the carrier will like provide those kind of services. So you can create the connection between the branch and the headquarters. Another is this is for the carrier that carrier provided the services. So those kind of mode that the prices will be expensive, but it is very reliable because the carrier can provide a high SLA. Okay. Another is that you only rent the internet connection because internet connection is much cheaper than the private line, and you create your own WAN connection. You can run like the GRE or run the like IPsec between the different between site and HQ, between the branch and HQ. So you can basically create a tunnel above the internet. Okay, so this is the carrier internet plus the VPN. Those VPN is enterprise deployed. Okay, so you also can create it, but since the internet do not guarantee the SLA. So, which means between the HQ and the branch, your SLA may got problem. But we have solution for that. That is SD-WAN. But SD-WAN we'll talk about tomorrow. Okay, today we will not talk about the SD-WAN. We only talk about the WAN interconnection. Okay, and also we have something else. We have the carrier point-to-point private line. Basically, it's a similar with those transmission and the MPLS private line. You can consider it's like the bare fiber, right? Those are the point-to-point. In most of the time will be used like inside of the city. Okay, most of the time between the data center, you will choose this. You rent a branch, bare fiber. And actually, we also have a fourth option, a fourth mode. Number 4 mode is some company, they have the rights, they have the authority to create their own private line, which means all the network belong to themselves. Some company have. Most of the time is a very large company. Okay, most of the time is like the nation company, state company, the nation company. Okay, so basically this is the mode that can be used to create the WAN interconnection. Okay, and most of the time, some enterprises when they create the interconnection, they actually will use multiple of them. Like they will use a combination of the of those mode. Like some company, they will lease one MPLS line and lease one internet line, and the internet line will be used as a backup. Okay. So here's a little bit of detail like about the WAN interconnection technology. For the carrier private line, so basically we have transmission and the MPLS. Okay, and transmission like we can between them we can use like SDH, MSTP, WDM, DWDM. MSTP is not that protocol. Okay, it's a device. so those kind of devices to create a layer 2 connection, or maybe a level 1, layer 1 or layer 2 connection between your headquarter and branch. So for this carrier private line, most of the time it is that for some company they need security and also need like a high service quality. They were trying to use this. Okay, so this is transmission private line, and also there's another private line is MPLS. So MPLS is for that those companies they have a little bit like security requirement, but for service quality maybe not so much. Okay, you just have like average service quality, or maybe a little bit better than like average plus those kind of service quality. If some companies they have this kind of demand, they can purchase the MPLS private line. So the prices will be cheaper than the transmission, but the service quality will also a little bit lower than the transmission. Okay, and some enterprises when they trying to use the private line, they will build by themselves, but not a lot. Few companies, few companies they have the rights, they have the authority to do that. And the second WAN interconnection and technology, second mode of the WAN interconnection is we can use the internet plus VPN. So the internet is just the internet. Okay, we can use like 5G, 4G, create an internet or fixed network to create to create the internet connection. You just basically purchase internet services from the ISP. So above this internet, based on this internet, the enterprises can use those following technology to create the interconnection. WAN interconnection, like PBTP. This is a very old technology. L2TP, this widely used. SSL VPN widely used. IPsec, DSVPN, IPsec also widely used. DSVPN and A2A VPN, those is point-to-mounting point VPN. Not widely used, but have those kind of technology. Okay. Some company use, but not a lot. Some. Okay, so this is okay. And here's a little bit like a common using scenario, application scenario for the WAN interconnection network. The left side, this is for financial services, which means this is actually the basically the logical topology for a bank. Okay, so since the bank actually they have very high security requirement and also have very high reliability, the services requirement. The SLA, they have high requirement for the SLA. So since the bank have a lot of money, so they will try to they will rent those kind of transmission private line from the ISP. And some other company, for example, there's a one enterprise, for example, some WAN enterprises. So for them, they do not have that high requirement for the services, or maybe for security. So they will use like the MPLS as a private line, and they will use the internet plus VPN, which most of the time is GRE over IPsec. It's IPsec plus internet plus VPN, those kind of mode to create the connection. Okay, a little bit of example. So let's look at let's briefly look at the technology which will be used in the WAN interconnection. First, let's look at the networking technology which created the connection. Okay, this networking technology, which means technology can create the connection. Okay, so let's look at the solution first, and this solution we actually talked before. That for example, transmission private line, use those kind of device and technology. MPLS, basically is the MPLS level 2 or level 3 based VPN based on the customer's requirement, and also Internet plus VPN, DS, IPsec, GRE, SSL, L2TP, etc. Okay, so between the private line and VPN technology, which one like people should choose? First, it's totally depends on the requirement for the customer, but those two technologies have some pros and cons. So let's look at it quickly. So for security, the security actually depends on the ISP, which means that if ISP want to make your security, then you will have. So for the ISP, they need to deploy the firewall. They need to trying to find some way to isolate the traffic between different tenants. Okay, so this is relatively high, but it depends on the ISP. And the VPN technology is very high because all the data you transmitted in the internet, it is being encrypted. So normally it should have high security level. And for secondary reliability, private line have a very high reliability. But for the VPN technology, the reliability is just okay because you see, because we created the VPN on the internet. So the internet, you can not guarantee anything. Right? Sometimes it just disconnected. Okay. Another is scalability. So for the private line, if the ISP wanted to create some new private line, it took quite a long time, right? You need to plan, you need to do the configuration, you need to put the devices to the customer, right? Create the connection. So it all depends on the ISP, whether the ISP is deploy enough access point or not. Okay. And the access point is not that AP, I mean the fixed network access point. Okay. So for the Internet VPN, the scalability, well, it's quite okay because basically you buy the internet and you can create. Okay. And the investment cost, the private line, of course, very expensive. And VPN, internet plus VPN were much cheaper because the internet, if you rent the internet, cheap, right? Very cheap. And for the support of the mobile users, of course, the internet plus VPN technology will be much better because for the mobile users, for the VPN, you basically just can use L2TP or SSL to directly connect back. But for the private line, I don't think it is very easy to do the mobile. And transmission bandwidth in the same price. The private line, of course, the bandwidth is much lower compared to the internet, of course. Right. So which customer should choose which kind of technology to create the WAN interconnection based on their services. Okay, whether they want to have high security, high reliability, or maybe they want just to lower the cost of the network. Okay, depends on the requirement. Okay, a little bit of overview. This we actually already talk about. Right. This is for transmission. This is for the MPLS. This is the enterprise build private line. This means that as we said before, the company have the authority to create their own network. Okay, some company have, so they can create their own private network. Okay, so and let's look at a little bit of detail of the networking technology. First is a private line technology. Okay, and private line, as we said, basically one is a bare fiber, and another is for the transmission private line, the SDH, MSTP, WDM, those transmission devices, and the third is for the MPLS private line. Okay, so by fiber, I guess everyone is kind of familiar with this, right? It's just a fiber, and you put one fiber in the one end, another fiber in another hand, and between them, it depends on the distance. If the distance like is exceeded 300 kilometers, you need to put another generation devices to like forward the light to use as a proxy of the fiber. And if the distance is lower than 300 kilometers, you can just use one fiber and directly connect two devices, two sites. So for the bifiber, most of the time you will use the inside the city. You will use inside the city because the bifiber is very expensive. But inside the city, since the distance is not so long, so the prices will be okay. And another thing for the bifiber, like the bifiber do not have a concept of the like bandwidth for the rent. You do not rent a bandwidth because for bifiber about the speed, it is totally controlled by the enterprises. The enterprises they can like put two devices, two transmission devices like DWDM or maybe SDH. Then you will have different bandwidth. For example, SDH like 2M and DWDM maybe is 400 gigabit. Okay, it all depends on the customer. So here's an example. This is for the college. College have two campus. One is in main campus, another is a branch campus. If they want to create a connection, they can use bifiber because most of the time in the college, those two branches most of the time is inside the same city. So the expenses will be okay. Okay. So another is for the transmission private line. So transmission private line means that you also like you purchase private the what do you call it, the transmission private line, and for example you are purchase 20 megabits. So those kind of private line you will purchase based on the speed because the fiber resources inside of the carrier you are shared with others. So you are purchase bandwidth. And for the SDH, MSTP, and DWDM, those kind of devices, since they are isolated the packet based on the time slot or maybe based on the light frequency, which means the tunnel you have from one side to another side, it is what we call the hard tunnel, hard pipe. The other tenant will not use your bandwidth. So for that, the transmission private line have a very high service level, very high SLA. And for example, some company will use this, like a bank or some other company, like government. Okay, they will use those kind of technique to create the WAN connection between the HQ and the branch. And the last one is MPLS, and I guess everyone is very familiar with the MPLS, like MPLS VPN, those kind of things. Level 2, level 3. Okay, so this MPLS VPN you also can purchase from the ISP. The ISP based on your requirements, they will provide different private line. And MPLS VPN also widely used. The cost of those kind of private line will be much cheaper than not much. I should say much cheaper, just one much cheaper than the transmission private line. Okay, and the service level is okay. Yeah, not too bad. It is okay. Okay, a little bit example. A very common one. Okay. By the way, any question you can type down, you can input into the chat window. Okay, and I will see it. Okay, so this is for the private line, which is the ISP private line, and let's look at how is the enterprises to create their own WAN interconnection. We can use the internet plus VPN. So let's look at those kind of VPN technology. So here in this slide, we classified the VPN technology based on their using scenario, based on their services usage. Okay, but you can have your own way to classify the VPN. Okay, this is just one way. If you want to create classify the VPN in another way, it is okay. But in here, based on usage scenario, we will classify the VPN. First is access VPN. Access VPN, also we can call it the VPDN, the Delta Up VPN, the VPDN. So basically, in the real network, we will use the L2TP as an access VPN for most time. And also SSL VPN is also okay, but not all the devices support. Is not all the devices can be used as SSL services. So L2TP VPN will be a little bit will be much more widely used. Not much more. Will be a little bit more how do I say? Have much more easy to be used compared to the SSL VPN. Another is the Intranet VPN. Intranet VPN means that I created the VPN connection between the two branch company, or between the branch and the headquarters. But those branch companies, they belong to the same company. So the Intranet VPN basically just means between the branch, between the headquarters, they are in the same company, they want to create a connection. This is Intranet VPN. And thirdly is the Extranet VPN. The Extranet VPN, most time, those VPN is trying to provide the connection for your partner, because you do not want to share all the information for the partner. You only want to share some of them. So the SSL VPN will be widely used in this using scenario, because SSL VPN will very easy to control the network resources. Okay, so let's look at the access VPN first. So the access VPN, we will talk here. We will mainly focus on the L2TP. Okay. Here is our overview. So no matter what, the access VPN network architecture looks like this. We will have the RAC access control to how do I say this? To create the connection, and access control will also. There's another device called LNS, the network services, and trying to create the VPN channel. Those VPN channel is what we call a VPN. Okay, so those access VPN can be used in the create the connection between the branch and the HQ, but also can be used to create connection for the remote customer, the mobile customer, right? So some employees have a business trip, and if they go into some other places, they can use L2TP to connect back to the company, to the enterprise. Okay, so for the access VPN, we basically have three types of the technology. First is PPTP. PPTP is a very old technology. We are not using this anymore. It is because the PPTP, first, it only can support the Windows. Okay, only Windows. Most of the time, only Windows can support that. And second, PPTP do not provide any security feature, which means if I have some devices can capture the packet, I can totally get all the information from the PPTP packet. Okay, so it's insecure. And another actually is L2F, but L2F is a Cisco technology, so we will not talk. But L2F basically you can consider is similar with PPTP. So here widely used is L2TP, this one. will be widely used as access VPN. So L2TP, basically they create a level 2 tunnel, and L2TP itself also cannot support the security feature by itself. They cannot support security feature. So L2TP most of the time will be used with IPsec. Will be used with IPsec. Okay. So for the live network, the L2TP will be widely used for the access VPN because for the access VPN, it means the remote customer, the remote employee, traveling employee, they're trying to connect back. They will widely use L2TP. And some company might use SSL. Also, some company will use this SSL. But as I said before, the SSL, this function, not all the devices support it. For example, I'm a router. The router most time can support L2TP, but for the SSL VPN, most time is not. Firewall can, but router not all the routers support it. So the L2TP will be much more, have much more, how do I say, it's more common. Like all the devices, all the routers can support it. So it will be easy to deploy. Okay, so so this is for the access VPN. And let's look at the Intranet VPN. So Intranet VPN basically means, as we said, it only creates the connection between the branch and between the HQ. And this branch and HQ, of course, they are in the same company. And besides the GRE, we actually have another DSVPN. So GRE, I guess everyone is familiar. It basically is IP over IP packet, IP over IP technology. They input a GRE header inside here, and above it, it is outer IP. This is inner IP, original IP. So they can carry this original packet from one side to another side and send into the enterprises. So this is GRE. This is GRE. And GRE things do not support encryption. It's not security. It's not secure. So most time GRE will be used with the IPsec tunnel, and it's GRE over IPsec. So inside it is GRE packet, and outside it is IPsec packet. So when the packet transmitted in the internet, all the packet will be protected by the IPsec, and when it's going to it, they do not need IPsec anymore, so they can just forward in. Okay, and but GRE over IPsec actually do have a little bit shortage. That the first is GRE is a point-to-point kernel, and IPsec configuration will be a little bit complicated. So there's another technology called the DSVPN. DSVPN is a point-to-multi-point technology, but about the detail of DSVPN, we will not talk too much. Okay, if you are interested, you can look at the documentation of the AI router. Okay, there will be a much more detailed description for the DSVPN. But you basically need to remember that because GRE is point-to-point and DSVPN is point-to-multi-point, it will be much more easy to create internet VPN. Okay, and also DSVPN can have another how to say another advantage is that sometimes the branch devices, the branch export devices, they are actually behind the NAT device. So under this circumstance, maybe you cannot create a GRE connection. You cannot. So under that circumstance, you can use DSVPN. And the DSVPN also you need to create the IPsec because DSVPN itself do not support the encapsulation. Sorry, encryption. Do not support encryption. So you also need to be used with the IPsec. Okay, so for the live network application for the Intranet VPN, most of the time we will use the GRE over IPsec. Although there's a lot of advantage for the DSVPN, but in the live network, not a lot of people are familiar with the DSVPN. So the GRE over IPsec will be much more easy to use, which means it is easy to use, which means it will be many companies will choose it. Okay, because it's easy to use, it's easy to manage. Okay. Okay, so this is for the Internet VPN, and let's continue to look at the Extranet VPN. So Extranet VPN basically means I will create the connection between the customer, between your customer, or maybe your partner, and yourself. Okay, so for the Extranet VPN, SSL VPN can be used as an Extranet VPN, and actually L2TP also can be used. Okay. But for the L2TP, we already mentioned before, so here we look at the SSL VPN. So why is SSL VPN will be used for the Extranet VPN between the partner and the branch? It's because the SSL VPN can support those four functions naturally. Web page proxy, file sharing, port forwarding, network extension. So with those four features, it will be very easy to control the resources by inside your company. So those customers, those partners, when they want trying to get some information from your company, it will be very easy to control which information is allowed to be exposed to the client. Okay. So here is an example for the application scenario for the SSL VPN. So for example, some partner or maybe mobile users, they were using this SSL VPN gateway to access the resources, the network resources, which you allow them to be accessed. For example, email, OA, ERP, web page, FTP, network management services, those kind of things. Okay. Okay, so basically this is networking technology, and they are using scenario. Any question? Okay, so let's continue, and let's briefly look at the reliability technology. And about the detail of those technology, we will talk in the next slide. Okay, so let's briefly look at the reliability technology. First, we talk about the link detection technology first, because if we wanted to provide the high reliability, we needed to be very easy to know whether my network got problem or not. So for the link detection, basically there will be two types of technology. First is the technology detect whether this link is connected or not, the link connectivity detection technology. Another is the link quality detection technology, which means that the connection is okay, but you may be facing a very high latency, or maybe you were facing a very high packet loss rate. So this is a link quality detection. So on the live network, for the link connectivity detection, most time is BFD. The rest of two, EFM and CFM, seldom used. Some, not a lot, a little bit. Scenario, they will use this. Most time is in the one last mile. In that scenario, they will use those kind of technology. And for the link quality detection, well, they can use NQA or maybe IP FPM or those kind of technology to to detect whether your network is okay or not. Okay, a little bit overview for BFD. I guess everyone also is very familiar, so we will go fast. For the BFD, this session, the result for the BFD session entry can be used in many layers. Physical, data, network, transport, application layer. All those layers can use the result for the BFD session. So BFD, we just talk a little bit. And another is NQA. And NQA actually can detect the quality of the network, but not very accurate, not in a very accurate way. Okay. So the NQA test, they have many different type of tests like TCP, DNS, web test, UDP test, ping test, etc. They have many testing way. But for the NQA, it had a little bit of problem because how is the NQA do the testing? It is like this: the NQA, they will create some packet and use this packet to simulate the real services. For example, I have some web, the real web traffic is running in this network. And how is the NQA can test whether this web traffic have high quality or not? The NQA doing like this. They create another HTTP packet and send out, and to see whether have high latency or not. So you can say that, but this way you cannot detect the real performance because you create some packet, you send it out. So basically, it's just a simulation. It's a simulation for the real traffic. So which means the result for the NQA is not accurate. So there will be another technology called the IP FPM trying to solve this kind of problem. And those picture looks a little bit complicated, but let's see it in a simple way. So basically, IP FPM will do one thing: is color the data packet. They will put a color inside of the IP header. Okay, this color just a number. Okay, like 1, 2, 3, 4. This color. And when it send out, there will be incoming port and outgoing port. Okay, so from ingress and egress, they were trying to calculate like because I will color the packet. So for example, in here I have 10 packets will be colored, and when it go out, we only have 9 colored header. So I can figure out there will be 10% of the packet lose rate. And also inside it, you can put some like timestamp and trying to detect the delay and jitter. If you got a delay, you will got a jitter, right? So this is IP FPM. So the IP FPM, since they put the color into the real traffic packet, so it will be much more accurate compared to the NQA. Okay. So a little bit using scenario, like here's for NQA, and or maybe BFD, like trying to, we can use in the floating load entry, float load entry, those kind of unit scenario. Okay, to detect whether this network, this load entry is okay or not. Right? If not, it will be switched over. And if you want to get the end-to-end link quality, you better you use IP FPM. It is recommended. Okay, and another is for the network and the service reliability. Since the last is for the detection, that I can detect whether my network is okay or not, whether it's connected or not, and if I connected. I detect the network is not so good. So what to do? So let's look at the network and the services reliability technology. First is for the device reliability, we can use the VRRP. Okay, so VRRP you basically know like how is the device is doing the switch over. It will be okay. It will be okay. So about the VRP, we just pass because I guess everyone is knowing how is this working. Okay. And let's look something different from the VRP. Okay, now I wanted to detect. I already detected the SLA, the link quality, use the BFD or maybe use NQA or maybe use the IP FPM. I detect whether this network is okay or not. Now we need to decide, should the services running in this connection or in this connection? Which connection I should choose? Okay, so here is some technology can help us to solve this problem. One is SAC, another is SPR. So what is SAC? It's short for Smart Application Control. Smart Application Control. So this one will help us to detect this traffic is which application, whether it's Twitter or maybe it is Facebook traffic or maybe some other traffic. Can use this technology to detect. Another is called SPR, Smart Policy Route. Since I know what is your traffic is, it's for example, it's a Twitter, and Twitter have their own requirement for the network. So based on those two networks, based on the IP FPM detection result, or maybe NQA detection result, or maybe BFD, the devices will say, okay, maybe this link can meet the Twitter traffic requirement, so it will sending this out from this link. So how to achieve that? So let's look at the SAC first. So SAC, you can the only function for the SAC is trying to classify the traffic. Okay, in the old time we can only use DSVP, but with SAC we can forget about the DSVP. Okay, it works in like this way. First, when the different type of traffic going to the network, forwarding into the network devices, the network devices will checking the application identification record, which means whether this traffic is being identified before or not. Okay, if it is identified, it will create a record, and I will follow the old record and trying to classify the traffic. And if I do not have any record, it will go into the FPI signature database first. So FPI means first packet identification, which means I will, based on the 5 tuple, the source destination, IP source destination port, the protocol, those kind of tuple, to classify the traffic. This is FPI. This is where you should do the configuration by yourself. And if for the FPI do not cannot detect or classify the traffic, it will go into the last SA signature database. So the SA signature database, it based on the software signature to detect, to decide, to classify what is this packet is. Okay, so for Huawei, it supports like around 6,000 signature. Okay. And after I use like IP FPM and NQA to detect the link state, and also we use SRP to classify the traffic. And now there are only one question left for us is how did they choose the link. Okay, of course they will use SPR, SAC to classify the packet, and SPR will be used to decide which path I should forward. Okay, so here's an example for the application scenario for the service reliability technology. So those two links use the BFD, FPM, NQA detect the network quality and use SAC to classify the traffic and use SRP to decide which traffic going to which link. Okay, that is the reliability. Any question? Okay, now let's briefly look at the queues. Queues we actually talked before. So here is the overview. I hope you still remember this picture. As I said, this picture will be very important. Let's pass this slide. And queues application outbound, we can use this traffic congestion avoidance or congestion management, or maybe traffic tripping to control traffic and send out. Another is HQs. HQs we also talked before. So here we just pass. Okay. Then there will be some other technology called FEC, forwarding error correction. This also will be used for the WAN interconnection because, as we said, the WAN interconnection sometimes the company will use the internet plus VPN, this kind of mode to create the enterprise's WAN interconnection. But since we are using the internet, we cannot guarantee the services quality. So we must have some way to correct the error, correction the error. So how to do it? They actually basically have two ways. One is called the AFE, AEC, AEC, yes. AEC is a head error correction. So basically it is TCP. The AEC means that I send out and in the other side I find it got problem. It drop some packet. So I'll tell those backend, and this backend will sending those packet again. So those traffic for those kind of way for the TCP will be good because TCP they concern is whether my packet can forward to another side in a low packet loss rate or not. So this is for the AEC care about. But for the FEC, they are thinking in a different way. The FEC works like this. Before the packet sent out, they will create some FEC redundancy packet. And if any one of them is failed, is dropped, is errored, in the other side, when the devices reach this packet, based on the redundancy packet, it can automatically restore for the for this one. Okay, it will automatically restore it. So this is FEC. So for FEC, we actually have two types of FEC. One is the DFEC, another is the AFEC. So DFEC means like how many packets I will create one redundancy packet. It is fixed. And AFEC, A is stand for the automatic FEC. Sorry, adaptive FEC. This is AFEC. And adaptive FEC means that if the network quality is good, so every 4 packets I will create one redundancy packet. And if the network's situation is not so good, which means the packet facing a high chance to lost the packet, lost the information. So the AFEC will add one one redundancy packet for two normal packets. Okay, so this is FEC. A little bit using scenario. Okay, a little bit of quiz. Which of the following are private LAN technology? SDH, MPLS, true or false? SRP technology can be uh, flexibility select ingress link based on the uh, link quality. True, true. Okay. Summary we just passed. Okay, so this is for this slide. This slide only ask the purpose for this slide is basically have will let the student have a basic idea like what is a WAN interconnection looks like, which kind of technology will be used for the WAN interconnection. Okay. Any question for this slide? No question? Okay. Good. So let's take a little bit break. Let's take 10 minutes break, and we will come back to talk about the key technology of the WAN interconnection. We'll talk about the detail of certain technology which will be used in the WAN interconnection. Good. Okay. Okay. 10 minutes break.